Do you know what Parkinson's disease is? Do you know who it can affect? Next on CTSI Discovery Radio, we'll talk about this neurodegenerative disease and what researchers are discovering and who could be at risk for Parkinson's. That's next. Good day, Southeast Wisconsin. You are listening to CTSI Discovery Radio, and I'm David Todd, your host for the next half an hour. On this program, we'll be talking about Parkinson's disease, from how doctors diagnose the disease to the latest in research and how you can help. But first, the Clinical and Translational Science Institute of Southeast Wisconsin is a consortium of 8 institutions, including the Medical College of Wisconsin, Milwaukee School of Engineering, Marquette University, University of Wisconsin at Milwaukee, as well as Children's Hospital of Wisconsin, Froedtert Hospital, Blood Center of Wisconsin, and the Clement J. Zablocki VA Medical Center. All 8 institutions collaborate to accelerate the discovery and development of new treatments and interventions that will improve our community's health. The process of developing one new drug or medical device can take anywhere from 10 to 15 years and cost millions of dollars. CTSI members are collaborating to develop new drugs or devices faster than ever before. At the Medical College of Wisconsin, Dr. Joseph Hill is the Managing Director of the Office of Technology Development and is pleased to report that the Food and Drug Administration has approved a new translational device coming out of the CTSI. Good afternoon, Dr. Hill. Thanks for sitting down with me. First, I hear congratulations are in order. Tell me about the news you received this month.
Well, we received word from one of our companies that's helping to develop one of our new medical devices, Somna Therapeutics, that they were granted clearance by the FDA, the Food and Drug Administration, to begin selling the Razaband in the United States. This was a long process for them, much longer than was anticipated, but they got their clearance, and actually a week after that, they sold their first unit to a doctor and a patient in Florida.
So in talking about the expense and the time that it took, can you tell me kind of an overview of how long this process took when it started and when it really kicked into high gear?
Sure. The process started, in our view anyway, when the idea for the Razaband appeared in Dr. Shakir's mind, and that's called the date of conception. And that was around March of 2010. Shortly thereafter, Dr. Shakir filed an invention disclosure with our office, in which he indicated that's when he conceived of it, and we got first word of what this device might be and what its function might be. So it began in March of 2010. So if we look at, today, March, if you will, or of 2015, that was a 5-year process. There were lots of steps along the way. Certainly filing a patent, and that took about 2 years to get that information together. Dr. Shakir presented this idea in what's called the First Look Forum here in Milwaukee, and attended by a number of investors. Make a long story short, a month after that, in March of 2012, Somna Therapeutics was formed. And then within 2 weeks, we had a license agreement with Somna Therapeutics. Within probably 2 months, they had raised almost $1.2 million in venture capital, and then began their clinical trials in October of 2012.
So have you seen any changes in this process, in the technology development process, since the beginning of the Clinical and Translational Award grant in 2010?
I think, generally speaking, the CTSI as an institute and the grant that it received to establish itself has done more than anything else to raise the visibility and importance of translational work, linking the basic concepts done in the laboratory and in the minds of our faculty to products and services and ideas that actually help patients. And there are a number of projects, technologies that have received support from the CTSI. So our disclosures are up, the last few years on almost 45%. And I think that's in part because faculty here at the Medical College and in our partners at the other institutions are thinking more about the broader marketplace for their ideas.
Dr. Hill, how important is it to the Medical College of Wisconsin that we have this technology development, that we have new therapeutics in the pipeline, that we're continually introducing more products to serve the people that come to us?
Well, I think it's very important. I know it is, because first, there's expectations on the part of our sponsors of our research, including the National Institutes of Health, that the discoveries and the work that goes on here is going to somehow benefit the public and hopefully the citizens of the United States. And so that's why in every grant application, our faculty do indicate, the value, the innovations that may come out of that. And Congress is constantly, providing oversight to the NIH and saying, how are we doing, in generating these new ideas. But here, is where, having the importance of the CTSI, the need to translate from lab, if you will, into some patient is very important. And if there are good ideas and they make sense from a standpoint of a patient, that is, someone would use it, a doctor would prescribe it, and there's a market for these products, then there is investment capital available to take it to that step.
Dr. Hill, I thank you for your time today and appreciate you sitting down with us. That's just one way the CTSI is working towards improving the health of the community that it serves. We'll take a quick break, and when we come back, we'll talk with the National Institute for Neurological Disorders and Stroke and find out how Parkinson's disease is defined and diagnosed.
There's a place that I know. It's not pretty there, and few have ever gone. If I show it to you now, will it make you run away, or will you stay?
We reached out to Dr. Beth Ann Sieber, Program Director at the National Institute for Neurological Disorders and Stroke, to tell us more about Parkinson's disease and where the research community is looking for help. Thank you, Dr. Sieber, for taking your time with us today. I appreciate that.
Oh, it's a pleasure.
First, I really just want to get kind of a high-level understanding of what Parkinson's disease is.
So my colleagues and friends with Parkinson's disease would say that it's different for each individual. But in general, Parkinson's disease is a progressive, degenerative neurological disorder of unknown origin that affects movement and some other factors of life as well. The average age of onset is about 60 years old, but there is also younger onset Parkinson's disease.
Right.
And in addition to some classic motor symptoms or problems with movement, there are a spectrum of other effects included in Parkinson's disease. People's sleep can be changed, their mood can be affected, their thinking can be affected. So in addition to movement, Parkinson's disease can affect quality of life for those people.
So, doctor, as you said, symptoms start to show in individuals who are around 60 or so, but it can be discovered as early as 30. How do we screen? How do we determine a diagnosis of Parkinson's disease?
That's a really great question. There are no laboratory tests that can give a definitive answer if a person has Parkinson's disease or not. Currently, we have neurologists making very careful clinical assessments to give a diagnosis, and that diagnosis is not actually confirmed until after death, when pathologists can actually examine the brains of persons with Parkinson's disease.
Interesting.
In the research community, there are a significant amount of efforts directed toward the discovery of what we call biomarkers, or biological readouts that can provide information on disease risk, diagnosis, and inform better treatments for Parkinson's disease. So that is a significant area of interest in the Parkinson's disease research community right now. And I should also say that the diagnosis of Parkinson's disease usually isn't made until after there are significant neurological changes. The brain seems to compensate up to a point. So one of the huge interests in the Parkinson's disease research and treatment field is trying to push back that diagnosis as early as we possibly can to start treatment and hopefully stop progression of the disease.
So when we look at Parkinson's, and you talked about biological markers, or what we call biomarkers, is there a certain set of those that researchers are looking for right now?
So they're looking in biological fluids, like a person's blood, for example. They're looking in cerebrospinal fluid. They're looking in the brain through imaging techniques. So there are a lot of different ways that we're trying to get a handle on biological signals or biomarkers. There's a lot of interest right now surrounding a protein called alpha-synuclein, and this protein is known to accumulate in the brains of persons with Parkinson's disease. So it's a pathological signature. And what researchers are trying to determine right now is whether there are changes in alpha-synuclein in the blood, in the cerebrospinal fluid, and whether we can possibly develop an imaging agent to track synuclein in the brain. So there's a significant amount of interest in that area right now.
So we're really at the infancy of Parkinson's disease research, aren't we? We
are. But we've learned so much in the past several years. We don't know what causes it, as I've mentioned before, but we're learning more about genetic risk factors that might contribute to the onset of Parkinson's disease, including the age of onset, believe it or not,
really?
And environmental factors that also might contribute to Parkinson's disease. So I would say we've made significant advances in those areas in the past several years, but there is some way to go.
Well, Doctor, thank you for this information.
It's been a pleasure. Thank you so much, David.
As Dr. Sieber said, the Parkinson's research community is putting a lot of effort into finding biomarkers that can give scientists new insight to what's happening to the brain of people living with Parkinson's disease. Researchers like Dr. Joseph Carroll, ophthalmologist, associate professor, and co-director of the Advanced Ocular Imaging Program at the Medical College of Wisconsin. Dr. Carroll, in your study of Parkinson's disease, you're looking at the retina, and you know that there's a connection between the brain and the retina. What are you looking for when you're looking at the eye and looking at Parkinson's disease?
Well, there's not just a connection between the brain and the retina. The retina is, in fact, part of the brain. And so what we're looking for is to answer some important questions about how the brain is affected by Parkinson's. And that's really the key to, I think, developing treatments for the condition, as well as monitoring disease progression and monitoring ultimately how the disease might respond in response to a treatment. And whether you do that at the level of the retina or the level of the brain, the traditional brain, probably doesn't matter.
So this is not only a way to see what's happening with patients with Parkinson, but it's also an easier, non-invasive way to get some insight of what's happening inside the brain.
Absolutely. The retina is an incredibly easy tissue to image. If you take any picture at a birthday party and you look at the red eyes that you see, that's actually light from the retina. It's very easy to image the retina. And in some cases, we can do so with single cell resolution. We're nowhere near that in imaging of the brain. We're imaging thousands of cells at a time. And so resolution is really the key. The better the resolution of your imaging tool, the better the sensitivity of your measurement. And so when we talk about trying to monitor how the brain is affected or changing in a disease process, we need as high a sensitivity as we possibly can get.
So when you're looking at Parkinson's in the brain or in the brain through the eye, is this the best look you've had so far inside somebody with Parkinson's?
Honestly, very few people have looked before. So can I say it's the best look? Maybe not, but it's certainly the first look. And sometimes it's that first look and you really don't know what you're looking at. And that's both frustrating but also encouraging at the same time. We know that there should be specific cell types in specific retinal layers that would be expected to be affected in Parkinson's, and we've seen that. You see some thinning of the retinal tissue that has been reported now in the literature, and we can confirm that. But there's other changes we see that haven't been reported in the literature. New things that surprised us. And so now the challenge is to try and chase those down and figure out what do they mean. Are they related to the disease process or some other feature of normal aging? And that's part of the challenge in working with aging and neurodegenerative disorders, is to disambiguate normal age-related changes with pathological changes. And we're not there yet. So we just need to keep collecting more data, both on patients with Parkinson's and other conditions, but also on age-related normal controls.
Dr. Carroll, let me ask you this. In your studies, when you're looking at people with Parkinson's, what excites you most about the information you're getting now?
Well, I can tell you what excites me is the fact that when we're looking at a patient's retina, someone with Parkinson's disease, it's the first time anyone's ever seen their retina. And again, it's their brain. We're looking at their brain in a way that no one's ever looked at it before. And so that's the excitement. That's the sort of the thrill of seeing something that no one's ever been able to see before. The challenge of the course is interpreting it and figure out where is it going to take us. If we can image protein deposits in the retina or loss of dopaminergic cells in the retina, that happens in part. What does that mean for a particular patient's prognosis, or whether they are going to accelerate faster or slower than another patient we might image? That's the uncertainty part. So that's not as exciting. That's a little daunting because it means there's a lot more work to do. But it's equally gratifying to know that you're doing something that is going to mean something with respect to patients that have this condition.
And in your research, do you have participants that are healthy individuals that you're comparing to people with Parkinson's?
Absolutely. Our research relies on research volunteers. You can have all the equipment in the world and all the grant dollars you would like, but if you don't have patients and families who are willing to participate in research, you don't have discovery. And that we're fortunate to be in an environment here at the Medical College of Wisconsin where people get that. The patients understand it, their families understand it, and they're willing to devote themselves and to contribute to the research process. But as important as it is to have patients embrace this enterprise, we need healthy controls, because as I mentioned, it's sometimes difficult to differentiate what's a normal sort of variant or age-related change versus a signature or an early indicator of a disease. And we're just at our infancy of understanding what those differences really are. And for that, this is why we continue to collect lots and lots of images on lots of people.
So if this really is the first time you're looking at somebody's brain through their retina without healthy subjects to compare it to, there's really no comparison. So it's really a first look without any kind of a subject to compare it to.
Yeah, in many ways you would consider the data, or in this case the image, to be out of context. And there's some cases where it's undeniable that what you're seeing is probably linked to their condition if you've never seen it before. And those more pronounced changes are probably not that meaningful because they're a little bit easier to measure. It's really the more subtle, cellular level or subcellular things that people can't currently image that are probably contain more information. And that's really where we really need more data at this point.
And that's where you can really see your excitement around the study.
Yeah, exactly.
Dr. Carroll, thank you so much for your time. If you would like to participate in Dr. Carroll's study, you can visit cto.mcw.edu and click on Volunteer Info. We'll take another short break, and when we return, we'll talk with the research foundation that the New York Times called the most credible voice on Parkinson's research in the world. That's next.
In this proud land we grew up strong. We were wanted all along. I was taught to fight, taught to win. I never thought I could fail. No fight left, or so it seems. I am a man whose dreams have all deserted. I've changed my face, I've changed my name, but no one wants you when you lose.
Don't give up, 'cause you have friends. Don't give up, you're not beaten yet. Don't give up, I know you can make it good.
Though I saw it all around, never thought that I could be a faintant. Thought that we'd be last to go. It is so strange the way things turn. Drove the night toward my home, the place that I was born, on the lakeside. As daylight broke, I saw the earth, the trees had burned down to the ground.
Don't give up, you still have us. Don't give up, we don't need much of anything. Don't give up, 'cause I believe there's a place where we belong.
Hey, and just a reminder that programming like this would not be possible without your support. Please contribute to the WMSE Spring Membership Drive going on right now. Call 414-799-1917 or pledge online at WMSE.org. For many Americans, the first time they had ever heard of Parkinson's disease was when a young actor named Michael J. Fox was diagnosed with young onset Parkinson's disease. Fox didn't go public with his condition until 1998. But when he did, he committed himself to Parkinson's awareness and research, founding the Michael J. Fox Foundation for Parkinson's Research in 2000. Joining us on the phone today is their Vice President of Research Engagement, Claire Meunier. Claire, let me ask you this. As the Vice President of Research Engagement for the Michael J. Fox Foundation for Parkinson's Research, what is your biggest challenge in getting the general public interested or engaged in research?
So I think, when we think about the general public being engaged in research, we're always going out with sort of a Parkinson's bent on that message. But I think our biggest challenge is really getting folks aware that people are needed for research. Sometimes we hear from patients that they thought that if they were needed, they would have been asked already to participate. And so we spend a lot of our time saying to people, did you know that trials struggle to recruit, and that, by participating, you can actually make a really important difference. And of course, once you tell people that they're needed and they're sort of interested to learn more, you have a responsibility to then educate them about what's involved in participating before you actually sort of ask them to participate in one particular trial. And so I would say that awareness and that education, when we're talking about sort of the large population, are probably the two biggest barriers that we face.
So obviously, one of the things that you don't have to deal with is at least awareness of the foundation or awareness of Parkinson's disease, because your founder, Michael J. Fox, has done such an amazing job of getting the word out that Parkinson's is a disease that can affect anybody. So let me ask, Claire, once people find out that healthy participants are needed for research, that everybody can support Parkinson's research in some way or another, what's the next step? What should people who want to support Parkinson's research do after they know that they're needed?
Yeah, so you're generous in suggesting that everybody knows Michael J. Fox and knows what Parkinson's is. I think we do still have a little bit of work to do on that front, but we certainly are fortunate to have someone who is so gracefully in the public eye and so open and willing to talk about his disease and his passion for research in Parkinson's at the forefront of everything we do. And so in that regard, maybe we're luckier than most. But I think, we talked previously about this, build awareness, let people know that they're needed, and then educate them about what's involved in participating. And I think for us, there is a key action step that people can take, and that is to register for a clinical trial matching tool that we've created called Fox Trial Finder. And the way that this works is actually very much like online dating. So just like Match.com for Parkinson's patients and individuals who are willing to serve as controls in Parkinson's research, and the sites that are looking for those people. And so what we encourage people to do is go to foxtrialfinder.org and register. And what registering involves for someone without Parkinson's disease is to tell us about any sort of other diseases or symptoms that other conditions that you might have, tell us about any familial connection to Parkinson's disease, and then some basic information about yourself, including your zip code. And then the trials will come in and actually enter the profile of who they're looking for and some information about what's involved in participating. And based on that, the technology does all the matching. So for someone with or without Parkinson's, they're going to get matched to a particular study that's looking for someone like them, and that's taking place in their own backyard. And so in that way, having that website and having, a key call to action and a place where someone can go when they're ready to act on sort of the awareness building and the education that we're doing is really critical to being able to really make an impact on the issue of trial recruitment. That's great information, Claire. What is that? What's that website again? It's www.foxtrialfinder.org. Excellent. And we'll make sure to post that on our website as well. Awesome. So that other people can find a clinical trial and get involved and help with Parkinson's and support that research. Well, I'm happy to be here and be able to share some information with your community. So thanks for having me. Thank you. I appreciate it. Claire tells me that there are currently over 400 trials on foxtrialfinder.org for people interested in supporting Parkinson's disease research. For other research opportunities right here in Southeast Wisconsin, visit cto.mcw.edu to find a clinical trial that's right for you. One last item. CTSI Discovery Radio airs the third Friday of every month, so make sure to mark your calendar and join us for our next show. And do log on to our website,
ctsi.mcw.edu for even more information about research and your health. Until then, CTSI Discovery Radio is produced by the Clinical and Translational Science Institute of Southeast Wisconsin, in collaboration with WMSC Radio. The show is engineered by Tom Crawford, with special thanks to Sandy Everetts and Drs. Herman Vietz and Reza Shakir.